Now for a binomial probability experiment, in order for us to do a binomial experiment, there has to be 5 cases, 5 characteristics. Let's see, the first one, the experiment consists of n identical trials. Okay, so everything has to be the same. If I'm gonna flip a coin, I'm just flipping the coin. I'm doing the same thing. I'm not including weight on one side, right? The trials that I do are identical. If I'm gonna go shoot free throws at a basketball court, I'm gonna go from the free throw line and I'm gonna do everything identical. So the first thing is the experiment consists of n identical trials. N is how many times I do it. But I'm going with all my trials are the same. The second thing I have to have, there are only 2 possible outcomes on each trial. We denote one outcome by S for success and others by F for failure. Sometimes we use letters P and Q. P for success and F for failure, okay? So what it means is that I have 2 choices. Either I make it or I don't make it. Flip a coin, right? You had either tails or no tails, right? Some people call it tails and heads, but let me just call it tails or no tails. I throw a free throw, I make it or don't make it, right? Again, I'm gonna use sometimes the P for success and Q for failure. Now, the probability of S remains the same from trial to trial. This probability is denoted by P, and the probability of failures is denoted by 1 minus P, which I wrote it as Q. Okay, so what is this to say, Mr. Leonzo? Okay, let's say I'm shooting penalties. I'm a soccer player and I'm shooting penalties. And let's say I have 80% chance of making a penalty kick. So my P is going to be 80%, right? My success is 80%, and my Q is going to be 1 minus 80%. So my Q will be 20%. As decimal, my P is 0.8 and my Q is 0.2. The trials are independent, so whatever happened to one trial does not affect the next trial. And the binomial random variable is the number of successes in each trial. As a matter of fact, we're going to use this formula. Probability of X is N choose X, P to the X, and Q N to the X. Mr. Leon, so what does this mean? Let me explain it in an example, okay? So let's say we have LeBron James is 74% accurate at shooting free throws. Okay, so let me write something really quick. I'm gonna say that P is 0.74. I'm gonna write this as a decimal. The probability that he makes it, the probability of success that LeBron James makes a free throw is 74%. It's at 0.74. My probability that he misses is gonna be 0.26. Right? I just went 1 minus P or 1 minus 0.74. So 0.74 or 0.26. Okay, so I know the probability of making it, the probability of failing. Out of 20 attempts, I just basically said n equals 20. You want to find the probability that LeBron James makes 18 shots. Round your answer to the nearest thousandth. Okay, so here, basically I'm saying x equals 18, right? So probability that he makes 18 shots is going to be 20 choose 18. You guys see how here basically x equals 18, n equals 20, right? So I'm using my formula, 20 choose 18 times 0.74 to the 18th, and then point times, let me use this here, 0.26 to the second power. Notice how 0.74 is the success, right? I know he has a 74% chance of making it. I want to see 0.74 to the 18th because I'm asking what's the probability he makes 18 shots. And then he's going to miss 0.26 2 times, right? Because there's a total 20 shots. Now multiply this out. I know 20, choose 18. Now, one thing I want to say, my answered probability, it's a number between 0 and 1. I expect my answer to be in between 0 and 1. If I'm off the range, let's say I get something like 2 point something, that's wrong, right? I'm expecting it to be between 0 and 1. My answer. Some of my work might be out of my range, but my answer will be between 0 and 1. So let's see, 20 choose 18. Right, remember 20 factorial over 18 factorial, but there's also 2 factorial at the bottom. I'm not going to do the steps because we practiced this yesterday. I'm going to say 20 choose 18, I get 190. Now, it's fine. That number being big, as a matter of fact, this first number sometimes is really, really big. It's going to show us on our calculator as a scientific notation because this number might be really, really big. Now, 0.74 to the 18th powered, right? 0.74 to the 18th powered. I'm going to use my calculator here. It gives me a bunch of numbers. So it gives me 0.004428. There's some more, but I'm just going to leave it at that. 0.26 to the second powered is 0.0676. Okay, so when I multiply all of this out, it gives me 0.056868. Oh, man, but one thing here, it says rounded to the nearest thousandth. So there's a thousand sounds like 1,000. Yeah, how many zeros are there in 1,000? 3 zeros. So that means my answer should be rounded to 3 decimal places. So I'm going to call this 0.057. That's it. I expected my answer to be between 0 and 1. So 0.057, that's okay. Now you want to see this as a percent, just multiply that by 100. So it's 5.7%. Okay, so knowing that LeBron James is 74% accurate, there's 5.7% chance that he might make 18 out of 20. But leave this as a decimal, so I'm just gonna call it 0.057. That's not bad. Let's take a look at my next example. LeBron James is 74% accurate at shooting free throws. Okay, so we know how to do that. Which sounds like what we just did. Out of 20 attempts, sounds like I'm reading very similar question, but now here it says you want to find the probability that LeBron James makes at least 18 shots. Round to the nearest thousandth. So at least 18 shots. So what does that mean? I'm looking for the probability that he makes 18 shots. I'm looking for a probability that he makes 19 shots. I'm looking for the probability that he makes 20 shots. And then I'm just going to add them all up. It says at least, so 18 or more, right? He's going to shoot it 20 times. Now, when I grab my calculator, I'm going to do the binomial probability of each. Remember, for probability that he makes 18 shots, I go 20, choose 18. Now I'm going to go 0.74 to the Let me erase this parentheses. To the 18th, because he's going to make 18 shots. And then 0.26 to the second. And that's going to give me, oh, let me type this on my calculator. It gives me 0.056868. Now, what's the probability he makes 19 shots? So I'm doing 20, choose 19. Probability of success is 0.74 to the 19th power, because I want him to succeed 19 times. The probability of failure is 0.26 to the 1 power, because I want him to fail 1 time. So probability he makes 19 shots is 0.017038. Okay, what's the probability he makes 20 shots? Okay, so I'm gonna go 20, choose 20. Probability of success is 0.74 to the 20th power, because I want him to succeed 1 time. I mean 20 times. Probability of failure, 0.26 to the 0 power. Would that just give me a 1? Yeah. A decimal to the 0 power is just 1, so it's not a big deal. When I multiply all of this out, I get 0.002425. I notice how I had to get the probability that he makes 18 shots, the probability that he makes 19 shots, the probability that he makes 20 shots, and then I'm just going to add them all up. I happen to have 0.076331. I highly, highly recommend do the work that I just show you here. Do it at the side. You will see how I got my numbers. But now, when I read the instructions, it says round it to the nearest thousandth. Okay, so thousandth sounds like 1,000. Thousand has 3 zeros. So this case, it will have 3 decimal places. So my answer will be 0. Let me write it in blue so we see it as a different number. My answer will be 0.076. Now here, my last example. LeBron James is 74% accurate at shooting free throws. Out of 20 attempts, you want to find the probability that LeBron James makes less than 18 shots. Round your answer to the nearest thousandth. Okay, one thing. Less than 18 shots. So that means probability that he makes 0 shots, plus the probability he makes 1 shot, plus the probability he makes 2, plus the probability that he makes 3. Let me just do dot, 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 all the way to probability that he makes 17 shots. I'd be like, holy smokes, that's a lot of work. Yes, that's one way of doing it. And let me just say it, a lot of work. There's a shorter way. I can find out, because there's 20, right? I can find out what's the probability that he makes the opposite of this. Remember, I have to find the probability he makes 0, plus the probability of 1, probability he makes 2 shots, 3 shots, 4 shots, 5, 6, all the way to 17. Let me find the opposite of this. So I'm going to find out what's the probability that he makes 18 shots, plus the probability that he makes 19 shots, plus the probability that he makes 20 shots. And whatever I get, I'm going to subtract it from 1. Because I know all the possibilities from he makes 0 shots, 1 shot, 2 shots, all the way to 20. it is 1 because that's all the possible probabilities. So altogether is 1. So instead of going probability of 0 plus probability of 1 plus probability of 2 all the way to 17, I find the opposite, probability of 18, probability of 19, probability of 20, and my result I subtracted from 1. Probability of 18, 19, 20, that one I know, right? That is 0.0763331. So 1 minus that. Okay, that's not gonna be bad. So 1 minus 0.076331. According to my calculator, I get 0.923669. But again, I see my answer here, my thing here. It says round to the nearest thousandth. Notice one thing I want you to want to emphasize is my work. I was not rounding much. My work, my answer. That's when I rounded. Rounded to the nearest thousandth. I know 1,000 is 3 decimal places because it sounds like the number 1,000, and I know 1,000 has 3 zeros. So my answer will be. It changes to red, so we see a difference here. 0. And I'm going to this place, right? This 6 is big enough, so it's gonna move it up. So my answer would be 0.924. That's how we do probability of a binomial theorem. And if you need any help, remember, I'm always just an email away.